Hi, everybody. I am Coraline Ada Ehmke. I work at apartments.com. We're hiring. I'm a principal developer there. And like our previous speaker, I do not have a CS degree. In fact, I'm a college dropout. But I'm an autodidact, which means that I know the word autodidact. Basically, I taught myself everything that I care about. One more thing. I'm from Chicago, and there are no fewer than 5 Corys in Chicago who do Ruby. I'm the one with the fuchsia hair. All right, so what is business intelligence? What do I mean by it? This is what we're going to be talking about today, basically. The stages of adoption of business intelligence, whether or not we can build it ourselves, and whether we should build it ourselves. So, of course, I have to start with the definition, right? So business intelligence means taking mission-critical knowledge inside of your company, organizing it to provide a historical perspective, and using it for real-time decision-making. It sounds pretty straightforward. It's reporting, essentially. Sometimes it's called data science. Sometimes it's called data warehousing, and there are all sorts of names for it. In the end, it's about taking the data that is essential to running your company, making sure it's accessible to the people who need it, and putting it in a form that's going to support the business actually making decisions moving forward. I like to talk about the 3 pillars of technology supporting business. Technology and business were not always partners, and we sort of take for granted now as software developers that if you're a company, of course you have a development team, and of course you have all these other things. So I think there are 3 main parts of how technology supports business. The first is infrastructure, and this is everything from the iron that the applications are running on to the accounting system, the HR system, all the stuff that I'm really bored by. The second sort of pillar is applications, and as developers, this is where we spend most of our time. We enjoy writing applications. We're delivering business value through the applications. We're letting the business scale, hopefully, through the applications we create. We're attracting customers by the applications we create. And the third tier is data. Data to a developer is often an afterthought. We use our data stores to store objects that we need in our applications. And once we're done with those objects, we're kind of done with thinking about the data. Maybe you have a report that you have to build for the accounting team or something like that. But again, once it's built, you're kind of done with it. And you're working off their requirements. So this is recognized as a sort of flaw as sort of a weak pillar. A lot of times, especially as the business gets larger. So typically, the business will want to address how to use the massive amount of data that's been built up and how to actually turn it into an asset for them. When developers make friends with data, though, Fluttershy gets her cutie mark, which is a MongoDB cutie mark, by the way, and friendship is magic, damn it. So I want to talk about how you actually go about adopting business intelligence systems. And I'm going to do it in 3 acts. The first 2 acts are typically how most companies do it. And unfortunately, they stop after the second act, throw up their hands in despair, and wander off in the distance looking for enlightenment. The third phase is the one that I'm proposing that I hope that all of you will go forward and build. So this is a Fiji Mermaid. I don't know if you're familiar with this. In the late 19th and early 20th centuries, there were a lot of traveling sideshows and circus shows. And the Fiji Mermaid was basically the torso of a monkey sewn onto the body of the tail of a fish. And there was some paper mache to sort of make the transition kind of smooth. And the legend was that it was caught by a fisherman in Fiji and now is like on display for everyone to see. And a lot of people believed in it. So if you're the kind of person who believes in the Fiji Mermaid, you're probably also the person who thinks you can report straight out of your transactional database. Everyone has done this at some point in time. Don't feel embarrassed about it. I have done it many, many times. I'm not going to ask you to embarrass yourselves by raising your hands, but I know you're out there. So what happens when you do this? Our data stores, our transactional data stores are built for what's it called? Transactions. So we have a lot of like distinct tables. Hopefully you're not doing single table inheritance. Distinct tables for each of our objects. There are complex relationships between them, maybe join tables, maybe join models. And when it comes time to report off of those, you get some really, really gnarly SQL. which brings with it performance issues. And this is something that one of the workshops is actually going to be talking about a little later. You might want to check into that. And to get around the performance issues, you decide, I can write better SQL than Arrow can. Good luck. What you find is that when you're doing reporting, you're impacting your production resources. Your servers will get slow, so you're like, I guess we better only run these reports at 1 a.m. I hope you're not global. And in the end, you throw up your hands like, these stakeholders just don't know what they want. Fine, I'll give them access to the database. Third circle of hell, I'm pretty sure. Which brings with it an increasing chance of catastrophic data loss. Don't trust him with your database. He's a master at Excel. He's a really nice guy. Looks great in gray. Don't let him into your SQL. So after you lose all of your data, because the guy in accounting messed up in his connection with his Excel spreadsheet, you say, we're going to go enterprise. And that means we have to bring in specialists. When a company gets to a certain size, they like to deploy what I call the blue and khaki army. And I'm sorry if any of you are in blue and khaki today. Not all blue and khaki people, okay? But they'll basically bring in consultants to say, we need a data warehousing and enterprise reporting system. So what gets built is an entirely separate stack from everything else. Usually it's a Windows server running Java. I'm sorry, I just threw up a little. You get nightly background jobs that are loading the data from your transactional database into your data warehouse. Generally, these are run with ETL scripts, extract, transform, and load scripts. They have no tests, and they're not in source control. So I'm sure everything will be fine with those. The schema in a data warehouse is optimized for reporting, which is a good thing, right? But it's reporting on day-old data. And maybe that's okay if you're selling, I don't know. I want fresh data. I don't know about you guys. But also, there was this old process that I'm old enough to remember called waterfall. Data warehousing requires a waterfall process because everything is so hard to do, you have to do all of your planning up front. And if you get it wrong, you get to start all over again and pay the consultants for another 3 to 6 months. And speaking of those consultants, they are not cheap. In the end, what you get is something really, really enterprisey. And if Edward Tufte were dead, he'd be spinning in his grave right now. So don't trust these guys with your data either. I'm sure they're nice guys. Yes, they're in khaki and blue. But the sandals are a mass demonstration of individuality that I've just never seen before. So Act 3, most businesses will give up at this point. They have a data warehouse, it emails reports once a week, and they sort of forget about it, forget about the promise of it. But there is a third option here, and that's what I call lightweight BI. So when a company realizes that their data is an asset and that it is too important to outsource, maybe it's time to go back on that build versus buy decision. The promise is real-time data put together by people who understand the data, the people who wrote the structures that the data is based on. Actually providing that real-time decision support. Using your existing development team and using your existing stack so you don't have to maintain those Java packages on the Windows servers. Because it's built by your existing dev team, you get to change your mind. You're investing in resources that will understand how it works and be able to change it when you change your business needs or when you decide that you need something a little bit different. You don't have to pay the army to come back and fix it for you. You can be iterative and agile again. You don't have to design every single report in the entire schema from the get-go and then implement it and then test it and hope that it's right. This is what we're all about, right? Being iterative and agile. That's not what business intelligence or data warehousing is about. So you can trust your developers. And it's a hard thing to do because data warehousing, business intelligence, data science, these sound like big, scary things. But the concepts may be a little difficult to wrap your head around at first, but in the end, it's something that any competent team of developers can wrap their heads around and can deliver value in this domain. And actually, they'll be better for your company having gone through that process. So maybe I've got you interested in the idea of lightweight business intelligence. How do you actually go about getting started with it? You want to collaborate. And I don't mean the sort of collaboration that we regularly do as Agile developers, where we work with our stakeholders and we sort of agree on things and then we run with it and iterate and show them often. I mean, like sitting down and getting out of your comfort zone, stepping away from the technology for a little while and trying to figure out what the business is actually all about. What are the important pieces of data? They're not your user model, they're your customer. So really working hand in hand with the people who are going to be served by the data that you're presenting to them. Not only to understand their needs, but so that you can communicate back to them what sort of things are possible. They may not know every aspect of what's being recorded. For example, they may not know that we're automatically, by using Devise, for example, recording the last login. So they can say, oh, how loyal are our customers? How many times did they log in? That's data that we know is there. They may not know it's there, and it may be of some value to them. So it's a two-way conversation. It's a collaboration. Then you want to formulate your questions. I like to think that data is there to answer questions. Some people think of it as an historical record or an audit trail. I think it's answering questions. And if you don't know what your questions are, there's no way you can find the answer. So work with your stakeholders to figure out what are the questions that we want to answer from the data. And these are generally the same questions that managers are asking their employees every single day. How many signups did we get? Or how, what's the life cycle of our customers? Is it getting shorter or longer for onboarding purposes? So as a developer, you're going to sort of start working on a solution and think about the data that you already have and start thinking about maybe if I took this data from here and merged it with that over there. What you actually want to do is take those inferences that you have, those instincts that you have, and turn them into facts. Now, fact has a very specific meaning in data warehousing and business intelligence, which I think is unnecessary. We all know what a fact is. A fact is an answer to a question, a truthful answer to a question. So if you can state your questions, you can figure out where the facts lie. And then you want to base a schema, a database schema, on what these facts are. You're not storing objects in state anymore, you're storing facts. Preferably you have a table or a document collection that answers one question, which means you denormalize a whole lot. And we're afraid of denormalization because we're taught from the age of maybe 5 or 6. Cow says moo, don't denormalize your data. Was that just me? You want to denormalize a lot. It's okay for data to be stored multiple times in different places as long as the facts that are stored are unique. Skip the clever graphs. In my experience, graphs are really pretty distractions that deliver about 0 value. The more ink that's used on a graph, the less informative it is, and the more it's lying to you. I prefer columns of data, side by side if you're doing a comparison, or grouped logically if you're not doing a comparison. They actually communicate things. They invite you to look at them and draw conclusions from them. Whereas a graph, you're like, yep, that sure is blue. So a recipe for success in business intelligence. Your mileage may vary. A lot of people will have their own opinions on the technologies you want to use. The important thing is that it's technology that you're comfortable with, that you know the ins and outs of, and it's your stack and it's your team that's doing it. So this is a recipe for success, not the recipe for success. I love Ruby. I think all of you do. Ruby is pretty awesome because it's built for TDD. And remember I said with data warehousing, with the ETL jobs, there's no tests. Everything is manual. We can actually test the assumptions about how the data is working, about how the facts are collected, and how they're being recorded and then reported on. Ruby is really easy to deploy thanks to, what was that company the guy was talking about? Heroku, yeah, they make it easy. Ruby's great at data munging. I'm old enough to have been a Perl hacker. And Perl was like really great at data munching. And I think Ruby owes a lot of its data munching capabilities to the fact that Perl existed. And there's some great visualization libraries for Ruby. A lot of them are on the JavaScript side these days, but they're really easy to integrate. So you can make, if you do need a chart, you can make really, really pretty charts that actually can communicate information. And Ruby has a variety of really powerful object relation mappers that will really come in handy when you're trying to build fact tables. This one's a little controversial lately. I don't know why, but Mongo's gotten a really bad rap. Somebody told me a couple of days ago, "You're the only person I know who's using Mongo right." I would say if you're not getting what you expect out of Mongo, you might be doing it wrong. I've never had a problem with Mongo, and I've been using it for like 4 years now. So anyway, if you're a Mongo hater, I don't care. Mongo has some great features. It has flexible schemas. You don't have to decide the shape of your data structure beforehand. If you change your mind, it's fine, and there are no migrations. Migrations are a pain if you have lots and lots and lots of data that you have to go back and touch. I can store hashes. I can store any object that I can serialize and deserialize or marshal and unmarshal, even if it's binary. I can store it, and not only can I store it, I can search inside of it in my database through my queries. That's pretty awesome. MapReduce is really cool if you have big, slow operations on tons of data you need to do. And as I learned the hard way, that's not good for reporting unless you're doing those sort of background jobs. The aggregation framework that's new in Mongo, relatively new over the last year, is really, really amazing and really fast and really hard to wrap your head around. But once you get it, you're cranking through data like you wouldn't believe. So I love Mongo for reporting. And the querying, like I talked about. But you know what? If you don't like Mongo, don't use it. If you want to use Mongo with Postgres, that's great. There's nothing that says that your Rails app has one and only one ORM. I use Postgres for transactional data, Mongo for reporting, and that makes me happy. So I talked about facts and storing facts. I want to talk through what I call a statistical model. Basically, a calculation is run every time data changes, not on demand, which means that the system is going to be really, really fast. It's going to anticipate the question that the user is going to ask of it and have the answer ready. And we're not talking about 24-hour delays. We're talking about, at worst, maybe a 30-second delay. Facts, not attributes. Stop thinking about a data store as storing objects. You're storing information, answers to questions. Because you're denormalizing, you don't have object graphs that you have to traverse. Everything is stored in a single document, denormalized. And you're optimizing for reporting. So everything that you want to report on is actually a field, in this case, in a document. How often is this member buying a trunk full of clothes? How much is the average value of it? What's the keep rate? All of these things that in a transactional database you'd be calculating on demand, that would be really, really slow and taking up a whole lot of memory. We have a single document that answers that question for a point in time. The other thing about it being a point in time piece of data is that you can actually recreate history and see how things have changed over time. That would be really, really difficult to do if you're storing a single object state at a time. The ETL processes that I talked about being really fragile, it ran every 24 hours. There's no reason now why they can't stream, why they can't happen on demand. So one of the workshop topic I'm going to talk about is like an actual implementation of this. But let's say you have a service-oriented architecture, what I like to call a small app ecosystem, and you have a messaging server in the middle of it, a messaging bus like Rabbit. You can actually have your data collection application listen to every message and record it, and perform calculations on things that change as a result of that new data coming in. So when someone does go to look at the report, it's up to date, and the calculations have already been run, and it's super fast. The calculations you do are testable because you have inputs and outputs that you can test, as opposed to having a human look at terabytes of data and say, it looks okay to me. They run in the background, which is fast, and the data is up to date, so it's all good. You might have heard that with SQL, or in some applications, you store the recipe, not the cake. I'm happiest when I'm storing the recipe and the cake, because I can't eat a recipe book, and I'm too lazy to cook, so it works. The other thing you'll want to do in this sort of system is build APIs to absolutely everything, because you never know where that data wants to be used. So don't just build the collection application and the storage database for a reporting application, because you might find that you want to brag on the front page of your site about how many transactions per minute people are doing on your site, or how much, if you're like GitTip, how much money are we raising every single week? And you don't want to, you can actually make that real-time data by establishing an API endpoint to your reporting server. So it lends itself to, APIs lend themselves to novel uses of data, and that's actually one of the promises of OO, is finding novel uses for code. So that's a win. Try it at home, experiment with it. It's not as scary as it seems. I wanted to walk you through an example of a lightweight BI system. I like to give my projects mythological names because I don't find, when I was in school, I was an English major, and I was really interested in comparative mythology and comparative religion. I don't find the naming problem to be a hard problem. But it's because I find names that I absolutely love, and that other people are like, what does that even mean? But it works for me, so. So this is a kind of typical small app ecosystem. On the left side, we have some maybe Rails applications, maybe Sinatra applications. We have a series of APIs in the middle. We have a message queue on the far right. We have our transactional data store, your Postgres data store, and your event data store, which is recording everything that happens. So all of the APIs, whenever an event is triggered, and the lines are all wrong, but I try to make it really pretty, and I guess that kind of broke things. Anyway, all of these APIs send out messages to the message queue. Oh yeah, that's right. Send out messages to the message queue, which then the event API captures a copy of and writes to the event data store. So someone signed up, someone bought something, someone closed their account, someone changed their preferences. All of these things are stored. Now these can be object state transitions that you record. These can be customer interactions down to the level of they scrolled the page. It can be really, literally any event that takes place anywhere in your ecosystem. It could be an admin logging in to check on an account. Record it all, because data storage is cheap. So everything goes through the reporting API. Everything goes through the event API, which stores everything in the event data store. And you have this reporting app, and you might have other apps that talk to your reporting API as well. So novel uses of data, everyone wins. So Leviathan, this is the Leviathan. Leviathan basically listens to every message that's broadcast in the SOA and records it. Don't think about business objects, think about events. I gave a similar talk to this one when I was first sort of toying with the idea at Ruby Midwest last year. And then at Windy City Rails, I had a guy come up to me and say, I tried to build Leviathan, and I failed twice. I don't think it can work. When I tried to go back and change the events, and I stopped him right there, and I was like, you tried to go back in time and change history, and things broke for you. I think science fiction authors have been telling us that for decades. So it was a little odd. So you're not storing objects, you're storing events. Events don't change. Here's an event model, and this is Mongo. I don't know if you guys are familiar with it. One of the things I like is like right up there in the field, the schema is declared in the model, which I think is really nice. So here's a record event, which basically creates an event with a label, customer signed up, an application, which application in the ecosystem was responsible for triggering it, and details, which as you can see up there, details is a hash. I can throw anything I want in there, absolutely any key value pair that I want, and I can search on those key value pairs. So I can say, search by ID, search by first name, show me all of the things that were bought by people named Sally. Searching on arbitrary data, really, really powerful. One of the other things that Leviathan did was provide explorable filters. So this is the UI for it. The left side is filters, like all the things you can possibly filter on, including the arbitrary data points. So you could say first name Fred or whatever like that. Even though all the records don't have first names, not part of the schema, they can still be searched on. And then the matching events showed up on the right-hand side. And if you clicked on one, it would open up. And on the far right, campaign, source, medium, content, those were related to landing pages. So those were landing page details that you were able to search on. So you build a nice little filter, and what you can do is say, save the filter. This is saving the recipe, right? And say, this represents people who signed up in April. And then you can store groups of people who match those criteria, not a relation, a formula that's applied to events to extract people or behaviors that are linked to each other, which is pretty cool. And break them into groups and study their behaviors. Study them side by side, note no graphs. Side-by-side data to see the people in December versus November, how much are they spending? All of these statistics, all calculated in real time as events change. Or you can dive into a single cohort. So, a few tricks that I've learned along the way. I'm really good at computering, by the way. Business intelligence is not rocket science, but it is not easy, and you will have to try several times before you get it right. And please don't come up to me at a conference and tell me it's impossible. I built it. If you can't get it to work, don't say Mongo doesn't work. Don't say MapReduce is broken. You're doing something wrong. Keep at it. You're going to fail many times. Keep at it, just like any other programming challenge. And use the tools you're most familiar with to make sure that you're getting the most value out of them. Collaborate like you really mean it. I talked about the collaboration. If you don't collaborate on something like this, you're going to spend a lot of effort and turn out something that no one's ever going to look at. And as a developer, that breaks my heart more than anything else when I finish a beautiful, elegant, well thought out system and nobody cares. That's death. Iterate fiercely. She looks pretty fierce. I like that. You really want to make really small steps, like smaller than 2-week sprints. Challenge every assumption and make sure that everything you're doing is exactly right. Make friends with your data. Like I said, friendship is magic. And when we start looking at data, we're putting data scientists out of work, which is unfortunate. But we're also like enhancing and multiplying the value that we as developers can deliver to the organization. So Coraline Ada Ehmke, yes, from that Ada, by the way. Bantic on Twitter and Bantic GitHub.io. Thank you all very, very much.